Hello and welcome to Algebra 1, Writing Exponential Functions. In this video, we are going to create exponential functions and solve problems involving exponential growth and decay. And we are going to write exponentials given a graph, a table, and exponential growth and decay scenario. So these are some of the standards that we're going to cover. These are from the Florida's Best Standards for Mathematics. And so let's go ahead and get started. And first we're going to start with writing exponential functions for tables. In Algebra 1, we're going to keep it pretty simple, and we are going to stick with the form y equals a times b to the x power. It's not until you get into Algebra 2 and a little bit later where you start dealing with some more complex exponential functions, but for Algebra 1 they keep it pretty simple. So the very first thing we want to do is determine our common ratio, and so that's going to be our b value. So from here to here I can see that we are multiplying by 2 and then multiplying by 2 and multiplying by 2. So that is going to be our b value. And we talked a little bit about the a value when we were doing some calculator and some graphing work in my other video about growth versus decay and exponential functions. But now we're going to get into how we would figure out what a is. And so now it says plug in one of the points for x and y. So I'm just going to use this first one for x and y. So for y, I'm going to put 6, and then I have to solve for a. And then b is going to be my common ratio, which is 2. And then my x value is going to be 1. And then we're just going to solve for a. So 2 to the first power is just going to be 2. And so now I have 6 equals a times 2, or 2a. And then to get a by itself, I'm going to divide both sides by 2. And I get a is equal to 3. And then now that I know that a is 3, I can write out my entire equation. Y equals 3, and then times 2 to the x power. And that's really it. So for Algebra 1, it's pretty simple. We don't get into any crazy exponents or anything like that. So this is basically what we're sticking to. So now let's do this from a graph. And so now with a graph, you're going to kind of do the same thing. And so we have y equals a to the b, a times b to the x. And then from here, you could either write out a table, or you could just kind of see what's happening to these y values. So I'm going from 1, 2, 3, 4, 5, 6, 7, 8. And so it's going from 8 to 4 to 2 and then to 1. So we can see that it's being halved here. And so that's going to be my b value. So I have a times 1/2, and then I can choose one of these points here to be my x and y. So I can use 3, 1 as my x and y values. So y is now going to be 1, and then my x value is going to be 3. And then I can plug that into my calculator. So I have parentheses, 1 divided by 2, close parentheses, y to the x, and then 3 equals, and then if I'm not sure about what this is, I can always change this back into a fraction, and I get 1/8. So now I have 1 equals 1/8 a, and then from here I can multiply both sides by 8, and I get a is equal to 8. So from here, I now have y equals 8 times 1/2 to the x power. And that's it. And in another video, I talked about writing exponential growth and decay functions and how we can use our reference sheet, and I covered that in our simple and compound interest video, but I'm also going to cover it here. So writing exponential growth and decay functions, we can basically use what's on our reference sheet, just minus the n value. And so for growth and decay functions, we basically just change it into y equals a, and no matter what, we talked about how whether it's this or this, whatever number we have outside the parentheses, that's going to be our starting point. So whatever you're starting with, times 1 plus or minus r, which is our rate written as a decimal, raised to t, which is our number of years. So if we don't remember how to do exponential growth and decay functions, we can always kind of use our reference sheet where it has our compound interest formula as a hint. If it's growth, it's going to be plus the rate. If it's going to be decay, or if it's decreasing, we're going to say minus the rate. So let's go ahead and get started. So with this one, it says from 2013 to 2014, the city of Austin, Texas saw one of the highest population growth rates in the country at 2.9%. And so that's going to be our rate. And it says growth rate, so we know that that's going to be a positive rate of 2.9%. And just like in my other video, 2.9%, we want to write it as a decimal. Percent means divide by 100. We can always put that in our calculator, and so clear out my calculator. 2.9 divided by 100 equals, and then I get 0.029. Okay, and then just like how we talked about, let's go ahead and start filling this in. So I get y equals, and then whatever we're starting with. So let's say that they gave us this scenario and they said, okay, if this trend were to continue, how would we write an equation? So it says the population of Austin in 2014 was estimated to be about 912,000. So that's how much we would be starting with if we are continuing that trend. And then we are assuming that it's growing by that 2.9%. So we're going to say 1, and then growing means plus, and then we have that 0.029%. And then if we're just continuing that, we would just put t. And so you might write something like this. They might also have you put this part together, and so you might see it as 912,000 times 1.029 t. And then if they asked us, like, okay, so if this were to continue and we're building that 29% per year, and then they said find out how much it would be after 3 years, we would say y equals 912,000 times that 1.029, and then we would fill in something for t. And so from here we would just put that into our calculator. So I have 912,000 times parentheses 1.029 close parentheses y to the x 3. And then this would be my new population. So my new population would be 993. And then if they asked us just to round to the nearest person, we could just say 99366, and then depending on who is writing your exam, sometimes they'll actually have you round this up because we can't have 0.2 people, and so sometimes you'll often see it written where even though we would normally round that 7 down and just keep it at 7, they would actually have you round it up to 8. And that would be how many people you have after 3 years. Let's do another one. So write an exponential growth and decay function. And so same thing, we're going to have, let's see, they're talking about an account balance. So let's say whatever's in our account. And then our initial amount A times 1 plus or minus the rate, and then raised to the number of years. So let's go ahead and read the problem. It says, in banking, a dormant account is one that has not been used for over a year. So you threw some money in and then you didn't do anything with it. A bank charges a monthly fee on dormant accounts of 0.8% of the account balance. So 0.8% is going to be our rate. We want to make sure that we're writing that as a decimal. So I'm going to just put 0.8, and then percent means divide by 100, and that gives me 0.008. And then of the account balance, one dormant account initially had a balance of $1,609. So they're asking us how much is going to be in the account. We started off with 1,609, and then we have times 1, and then remember they're charging us a monthly fee, so we're losing money, and so that's going to be minus 0.008. And then this question is kind of a tricky one because they're saying after about a year, how much would we have? And usually T represents the number of years, but we can't forget that they're charging us a monthly fee. So this is happening 12 times within that year. So we're going to put a 12 here to represent that it's happening 12 times. And then from here, we're going to go ahead and stick that into our calculator. So we have 1609 times that 1 minus 0.008 close parentheses y to the x 12. And that gives us about $1,461. And so kind of a trick question on that one, so just kind of be careful. And so even on your reference sheet, it kind of tells you here that number of time periods times the number of years. So you always want to think about how many times is this happening, and with that monthly fee it's going to be 12. So just kind of be careful with that one, okay? And that sums up our video on how to write exponential growth and decay functions, whether that's from scenarios, graphs, and tables. And I hope to see you in the next video.